Hey guys, how's it going? So in this video, we're going to be reviewing yet another example of Dijkstras algorithm. So here we're going to start with, again, this node 0. And I also forgot to mention, uncompared to the previous video, I won't be assigning each node a letter just for the sake of people who don't use letters for the nodes. So we are starting here at node 0, okay? Which is actually our first node, so it has a distance of 0 to itself. That is why it's assigned the value of 0. Now, the next thing we have to look at is the next possible nodes that we can go to, which would be these three. Now, the distance between this node and this node is 5, so we have to update the value of this node to 5. Now, the distance between this node to this node is 1, so we're going to update the value of this node to 1. The distance between this node and this node is 3, so we'll be updating the value of that node as well. Now, from these three possible nodes, we have to deduce which one has the smaller value, and we are going to be going to that node next. So this node has a smaller value, so we're going to create a back pointer just so we know where we came from. So this would be our current node right now, and the value of this node would be 1. These are now permanent nodes because they are the shortest distance. Now we have to look from the current node that we're in to the other possible nodes, as well as updating the other possible nodes that we can go to. So from here to here, the value of this node would be assigned 4 because 1 plus 3 is 4. In other words, the same idea of 1 plus 3 is 4 is the same thing as saying the distance from here going through here, passing through here and reaching here is 4. That is why this distance, this value of the node gets assigned the number 4. So now we have to update these two values if possible. Now, going from here, we have a distance of 1. Now, going up here, 1 plus 5 would be 6. Now, this is greater than the other possible steps, so we are not going to be updating this node. It's better to have a smaller value rather than to travel 6. So now we're going to look at this node. Now 1 plus 1 is 2. The distance here is 1, so 1 plus 1 is 2. Now this value gets updated. So we're going to be erasing this. Okay, and we're going to be updating the value to 2. Now we have to choose between these three possible nodes which one has the shortest distance, which would be this one, number 2. So we're going to create a back pointer right now, and that currently is our shortest distance. So we are currently now at the node at the bottom, which has a value of 2. Now from here, we have to update the values, and we're not going to update the values that we have already passed through because those are permanent nodes, and also it's called the shortest path algorithm for a reason. We don't want to go back. So now we're going to go to this only possible node, or we also have the option of going from here to here or from here to here. But that's obviously not optimal, so we're at the node at the bottom that has the value of 2. Now we have to update this this value because 2 plus 1 is 3. So it's no longer better to go straight across, but better yet to go right, down, and then this way. So this would be assigned a different value at this time, and we'll change the value to 3. So it's better to go to this node because distance would be 3 rather than go from this node to here because the distance would be 5. So this one is best. So we're going to create a back pointer just so we know where we came from. And now we are currently in node 3. At this point, we also have to consider the possibility of going from this node to 5, because let's say, for example, this weighted distance is not actually 1, but instead, let's say that instead of 1 it was, let's say it was 6. Okay, so at this point we're here. 3 plus 6 is 9, so it would make no sense to go from here to here. Better yet, it would be best to go from 0, this value 0 node, to here. So at that point we would create a back pointer from this node to this node, and that would be the shortest path. But that's currently not the case, and so in which case it would be best to go from here to here, and we would have to update this value because 3 plus 1 is 4, and that is less than 5, so it's better to go around than to go straight to that node. So we're going to update the value to 4. So knowing that that is the shortest distance, we're going to create a back pointer so we know where we came from. And that concludes it. We have passed through every node, and we have found the shortest distance from here to the middle, down, up here, and then finally here. So that is the shortest distance for this graph. I hope you guys enjoyed it. If you guys have any questions, please let me know in the comment down below. And don't forget to subscribe, guys.